So for this problem, it's basically using sine and cosine because that allows us to find the angles and the magnitudes of this. And really, for the answer, we have to find what the magnitude is, and that tells us what the momentum is, and also the magnitude here. So how we answer this is all the signs in the PI direction is 350 cosine of 60 plus 350 cosine of 60, sine of 60 in the j direction, and p final is 320 cosine of 30i minus 320 sine of 30i. So then we can combine like terms, so we can put all of the i's together and all of the j's together, and we have to multiply that by the mass which is given, which is 20. So once we simplify that, we know that the momentum equals the force times the change, which is the impulse. So when we find first the magnitude, we have to get the square root of I and the square root of that j value. And each of those are squared, so that we have here negative 9,043 squared plus 5.19 times 6. The square root of that gives us 6,720. Now we divide this number by 1,000 so that we can convert it into newtons, and we're left with 6.7 newtons per second, and that's our answer.